It's from an AS level paper. It's worth 4 marks, as you can see here, and the first half's about some units and the second half is about density. So looking at the first part of the question, 12a, it says, a student writes 4 incorrect statements shown in the table below. The error in each statement is circled. Write the correct answer for the circled unit or number. One has already been done for you. So the first incorrect statement that's done for me already says the weight of a person is about 700 kilograms. Straight away alarm bells are ringing because I know that weight is a force, and as we can see they've corrected it to newtons. Second question says the atmosphere exerts a pressure of about 1 × 10⁵ Newton meters squared, and that's circled. So I know that's the thing that's got the error. Now just thinking about it, I know that pressure, P equals force divided by area, so I know that should really be newtons divided by meters squared. Question says newtons times meters squared, so I need to just quickly change that. It should be Newton meters to the -2 instead of Newton meters squared. Force of 1 Newton may be written as 1 kilogram, meters to the -1, seconds to the -1. Again, just knowing a quick formula, I know F equals ma, and the units for that are kilograms meters per second squared. So I can see straight away that's why it's a problem. Just using the formula that I know off by heart, I can put that in right away. Third question, it hasn't actually circled it on this one, which isn't very good, but it says 1 gigawatt is 10 times bigger than 1 megawatt. Now I know giga, the prefix, means 10 to the power of 9, and I know that mega, the prefix, means 10 to the power of 6. So the difference is 10 to the power of 3, which I know is 1,000 times bigger. So the answer that they should have given is 1,000 times bigger. If I got all of those fine, I'd get my 2 marks for that part. The second part of the question, part B, says this. Figure 1.1 shows the apparatus used to determine the density of glass. And I can see this is figure 1.1 here. There's a glass test tube, a measuring cylinder, and currently the water level is measuring at 75 centimetres cubed. Glass test tube has a mass 1.6 × 10 to the -2 kilograms, and the measuring cylinder is partly filled with water. As we can see that in the diagram. The test tube is gently pushed into the water until it's fully submerged, as shown in figure 1.2, which is over here. And we can see in that diagram the water level is now up to 82 centimetres cubed, where before it was 75 centimetres cubed. It says the level of the water, as we've noticed, has gone up from 75 centimetres cubed to 82 centimetres cubed. Calculate the density, which is what they want to find out, so I'll just put that in there, of the test tube in kilograms per metre cubed, and that's really important because they want that in a very specific unit, which is different than the units given in the question. So hopefully I'll know, and actually this formula is given on the sheet if we didn't know, that the density is found by doing mass divided by volume. Happily, in the question I already saw that the mass was given to me, 1.6 × 10 to the -2 kilograms, and I need to divide that by the volume. To find the volume of this glass test tube, I need to remember Archimedes' principle, which is that if an object sinks in a liquid, then it displaces its own volume in liquid. Now the displacement that's happened here is the difference between the initial volume here and the final volume here. In other words, 82 centimetres cubed minus 75 centimetres cubed. That's 7 centimetres cubed. And I'm being very careful just to write that unit there to remind myself not to be foolish and put that straight into the equation, because I need that answer in kilograms per metre cubed, not per centimetre cubed. And this is the point where most people will make their mistake. We need to remember that 1 metre is 100 centimetres. 1 metre squared, though, is 100 times 100 centimetres. In other words, it's 10,000 centimetres squared, or 1 times 10 to the 4 if we're being A-level physicists, centimetres squared. And then 1 metre cubed, in fact, is 100 times 100 times 100, or 1 million centimetres cubed, which as an A-level physicist I'd write as 1 times 10 to the 6 centimetres cubed. Armed with this information, I can now convert my 7 centimetres cubed into metres cubed, the way that I can do that is just to do 7 divided by 1 times 10 to the 6, which is the number of centimetres cubed in a metre cubed, and that will be 7 times 10 to the minus 6 metres cubed. I can now go back to where I was before. I'd got the mass already, I was just waiting for the volume that I knew I had to convert. I can put that in now, 7 times 10 to the power of minus 6 metres cubed. I don't know why I put the minus sign there, apologies. And then I can work that out, just put it into my calculator and get an answer. The answer that I should get is given, needs to be given in standard form, which is quite important, and I should find that it's 2.3 times 10 to the power of 3 kilograms per metre cubed. Now, I have put that in standard form. A common mistake in this question would have been to write that as 2,300 kilograms per metre cubed. However, we know that the examiners are very keen for us to use standard form, and in fact writing this answer here would have left us with -1 mark. So really we don't want that at all. We do want this answer here in standard form. With those things in mind, you'd have 4 marks from the examiner.